oil and gas companies have invested significantly in offshore infrastructure and assets for oil and gas production, including platforms, pipelines, and deepwater drilling technologies and capabilities. As entities seek to diversify and apply their skill sets toward energy transition, many are looking to apply this knowledge to offshore wind development, while others are considering co-production plays for offshore assets like tidal and solar energy. But offshore geothermal has largely been overlooked as an opportunity, not only for greening offshore operations, but as an avenue for transforming offshore operations entirely. Can we harvest the co-produced heat from offshore operations effectively? Could offshore platforms become green hydrogen production facilities powered by geothermal energy? What are the technology, cost, and regulatory barriers standing in the way of leveraging geothermal energy offshore? Let's explore.
Hello, and a very good day to all of you out there for the first session of today at Pivot 2021, Offshore Geothermal, Obstacles and Opportunities. My name is Mari Brommer. I'm going to be your moderator of today's session, where we're going to explore two favorite topics of mine, offshore and geothermal. And I have with me four fantastic panelists. I have Roy Robinson, I have Rob Crossley, I have Kirsten Pasterell, and I have Danielle Marino. I am going to ask each of my panelists to shortly introduce themselves, after which we're going to quiz them on exploring with all of you out there. And please do not hesitate to ask questions in the chat on the vision for geothermal, the opportunities out there. What do we mean when we speak about geothermal, and all the opportunities that together collectively we can explore by thinking outside the box. Roy, I'm going to start with you for your opening remarks.
Hi, I'm Roy Robinson. I'm the CEO of Excipio Energy. We're an offshore renewable energy company, and we use that term specifically because we don't focus just on geothermal or offshore wind or wave. Our patents tend to center around our platform, which is to integrate all of those things together into a single system. And what we have really looked at the geothermal for is the synergies it would have with things like OTEC and aquaculture and the various other ways you can leverage the other renewable energy sources to reduce the parasitic loads that come with geothermal.
Excellent. Very exciting to have you. Thank you for taking the time today. Rob, over to you for your introductory remarks.
Hello, everyone. Rob Crossley. A bit of my technical background might help. I did my PhD in the Kenya Rift before anybody was drilling geothermal there, so a long time ago. Then 9 years in the University of Malawi as a lecturer with huge rift faults and hot springs along the side of that. Again, I was ignoring geothermal, trying to get a job in the oil and gas industry. I got that and came to North Wales 35 years ago, working as a sedimentologist, then a reservoir geologist, then a petroleum geologist, then looking at global Earth systems and plate models. In the last 20 years, CGG has been doing geothermal work, mostly in geophysics around the Ring of Fire. And I joined the geothermal team a couple of years ago to try and help us think about expanding away from traditional targets. So that's me. Thank you.
Fantastic. Happy to have you and looking forward to your vision as well, Rob. Danielle, over to you for your introductory remarks.
Hello, virtual audience. I'm Danielle Marino. I'm working as a Surface Technologies Manager in the Repsol Technology Lab. You probably know that Repsol has a commitment for net zero emissions, so we're leaving no stone unturned. Just like Roy was saying, we're looking at all the portfolio of opportunities to increase our energy efficiency, to reduce our CO2 footprint, and to have the right combination of renewable energies that are valid onshore, offshore, elsewhere. No? What do I bring to the panel? As Repsol, we have been analyzing our portfolio of assets for repurposing well. I can share some experiences on that. And also our exploration teams are working for looking for opportunities as well. As a technology center, we have developed a lot of products for our E&P operations, and we know that they can be pivoted as well. It's not only pivot, but you can also pivot products to support geothermal systems. And maybe on a more selfish note, I also want to learn from the rest of the panelists what are the opportunities that they're seeing in offshore geothermal.
Excellent. Great to have you on board today. Kirsten, over to you for your introductory remarks.
Hi, good day, everyone. Firstly, I'd like to say how exciting it is to be invited alongside my other panel members to discuss a fascinating proposal that's offshore geothermal. My name is Kirsten Pasterell. I'm founder and CEO of ZGen Energy, and we're a young geothermal startup based in Aberdeen, Scotland. We are firm advocates that geothermal really is everywhere, and that's why the ZGen portfolio is a mix of both heat and power projects in the on and offshore space. And specific to the offshore space, we lead the Aquarius Geothermal North Sea Consortium, with the focus on developing offshore geothermal opportunities in and around existing oil and gas assets. And we already have a number of offshore clients. So this is a super relevant discussion topic for us, which we are delighted to be involved in. Thank you.
Great, Kirsten, thank you. And also you, I'm very happy to have you today on board. And I'm going to stick with you for the moment, Kirsten. You're going to be my first target for asking the question, what do we mean when we speak about geothermal energy offshore? And especially in light of your work that you do, the focus you bring to that, especially the startup you just spoke about. But really, what's your focus and what is your vision for offshore geothermal?
Well, thanks, Marit. That's a great question to kick us off. We've been involved in a number of studies looking specifically at offshore geothermal product adoption, you might call it. And typically the starting point is using co-produced fluids to decarbonise offshore production, moving into repurposing to aid the energy transition, and finally, boom, the blue sky stuff, pure play offshore geothermal. But what does that journey look like? I mean, co-production is the low-hanging fruit. So how does it specifically benefit an operator? Now, in the first instance, allows them to decarbonise existing hydrocarbon production in line with meeting net zero targets. Here in the UK, offshore power generation, so that's purely to facilitate hydrocarbon extraction, accounts for around 10% of the UK's total energy supply emissions. Meanwhile, on the UKCS, on average, 2.5 times more water is produced than hydrocarbons. Now, on some fields, that number is much higher. It can be as high as 10 to 25 times more water than hydrocarbon production. So we already know we have a geothermal proven reserve. Furthermore, in investment terms, the capex is largely already invested. The exploration risk doesn't exist, and there's an obvious route to market because there's a need for power offshore. And actually a very quick route to market when you measure it against onshore geothermal projects or indeed other offshore renewable energy products. So the business case itself is strong. So co-production affords geothermal the proverbial foot in the door, right? It's a fact that people nucleate around projects, and demonstration and representation are crucial in this space. And it also provides a fabulous vantage point to look beyond co-production to the larger role that geothermal can play on the offshore stage in years to come. Now, I'm speaking about transitioning assets where geothermal provides a baseload complementary to other offshore energies, and further out into pure play offshore geothermal feeding into offshore networks. Now, those models will probably look very different to the co-production ones. And that means we'll need to pioneer both new tech and business models to get us there. And that brings me to my final point here. And that is, offshore, we have access to massive data sets associated with producing assets. Data sets that a geothermal developer would quite frankly bite your hand off for. So we also have access to potential demonstration sites, and we're going to need both.
Excellent. That is a fantastic way of describing what it is that you focus on and why you think this is such a huge opportunity. I am going to move over to Roy. Roy, You already explained in your introductory remarks a little bit about Excipio, but talk to us about your vision and why geothermal offshore, why it matters and why we should pursue it. Where does it stand for, in your opinion?
I come also from an oil and gas background. I did that for 25 years, building big steel offshore. And what we noticed is that the renewable energy industry in general, and specifically offshore, is very siloed. The wind guys don't talk to wave energy guys. Wave doesn't talk to currents. Nobody talks to the ocean thermal guys because they're crazy. And hardly anybody mentioned offshore geothermal back 5 years ago. But the energy companies are all looking for something to lean on to replace the oil and gas, which is a hole in the ground that money comes out of. And so they keep looking at single technologies. And so what we wanted to do was to try to bring them together, because you share all these CapEx and all of the permitting and all of the manning costs and the maintenance. So even as good as geothermal is, or as good as some of the wind energy is, or the wave devices, they will all get better if you combine them. If you combine them in a systematic and a planned way. You can't just strap things on and have it work out, which is what our focus has been and our passion is. I mean, this is basically, I wanted to be a marine engineer when I was 14 and studied it. And this is the stuff that excited me back then, way back before the internet and the rest of it. So to see geothermal starting to come out, and as Kirsten correctly pointed out, we have a lot of oil and gas fields out there. I'm in the process of trying to study how we can repurpose the assets in the Gulf of Mexico. We're doing that study for the DOE. And what we're looking to do is to look for specifically things like water drive reservoirs where you can do a binary system, a closed cycle. You pull it up and put it back in. If there's any hydrocarbons to be stripped off, you could do that as well. But at the same time, closed systems are a far more reliable way to do it. But there's other things that people haven't looked at, which is OTEC, which is ocean thermal energy conversion, requires warm water. So it's limited to tropical areas. But the technology developed for it runs on a 15°C difference. And so if you pair that with geothermal, what that's going to allow you to do, you could actually have that same technology, but apply it in places like the North Sea or off the coast of New York, where the waters are too cold to do it based on the water. But if you pull up a little bit of geothermal heat and combine that with the OTEC energy system, you suddenly start to make energy that's baseload power. This is 24/7, not wave energy. Those systems tend to have very high parasitic loads, and then that's what you would defer using the wave and the currents and everything else. So you would then keep that base load higher and more constant, reduces the need for energy storage, peaking plants, all of those things. And then we took it one step further after that, which is if you get all these things and you're already going to build these big structures and you're going to have these fields that don't look like oil and gas fields, because you've now got, instead of one platform, you're going to have 100. To not put things like aquaculture or bioalgae production. And if you start thinking about it from the beginning and you start with that blank piece of paper and you just say, how does this feed into that? You can create these organic systems. I mean, they're almost like kind of feeding upon themselves, of which geothermal has a very central part, right? I mean, it's, as Kirsten pointed out, it's base load. We've got the data from all the oil and gas fields, at least in the places like the Gulf and the North Sea and over in Indonesia and a few other places in the world. Brazil is one place that we're focused on. We actually have a subsidiary company in Brazil. And all of these things combined can be leveraging the oil and gas infrastructure, the knowledge we have, the drilling skills. If you take it to onshore, which is not our area, but you've got all the technology they built for the fracking, making the wells less expensive. Plus in the States, for example, there are literally tens of thousands of wells waiting to be P&A'd. Rather than P&A them, you could re-enter them if you have a closed system. So that's where our focus is more on the closed and binary systems, not the classical geothermal. And the last part of our, why we're kind of involved in this, even currently, is I've seen some people talk about going out to the ocean vents and using the temperature, because you can get to the geothermal resources very easily when you go over by the geothermal vents because it's very close to the surface. But that's a super sensitive biosphere. And so that's one that we caution against. When the oil companies have asked me, is there value in looking at this? And I'll tell them, if you do that, you're going to get an awful lot of people really, really concerned, because those things are systems that have been there since before the dinosaurs, but they're also fairly fragile. And so if you mess that up, it would not be good. And there are other ways to pull out the geothermal. In particular, one of the other things I advise people on is to not try to find a place where I can drill a geothermal well, but find the well and say, okay, this is the heat it's got. What can I do with it? So
Right.
you turn the question on its head. Instead of I need to find something that's 150 degrees. Okay, I've got one that's 200 degrees. If OTEC works on 15 degrees, I can probably do something with that.
Oh,
But anyway,
nice.
that's where our passion comes from, is just trying to get those things all integrated together.
Fantastic. And also it's very broad as you describe it, and also maybe certain areas that you have looked into and that might be an obstacle for that. I'll come to you later on that, because that's quite an interesting one. Thanks. Rob, I mean, we discussed a little bit, let's say a year ago, I think we met for the first time, Rob, when we were discussing international waters and geothermal everywhere. So over to you, over to your vision for offshore geothermal. What are your ideas? And explore with us in the audience how you want to position offshore geothermal.
Okay, Marit. Yeah, we've come a long way in 12 months since then.
Yeah.
Imagine we've been thrashing away on the geology of all of this. First of all, absolutely sort of extending what Kirsten was talking about. In the relatively shallow waters, say 200 meters less, because we've got global data sets in CGG and Robertson's. We've been looking at international waters like forever. So we're able to look outside of the places where there's a lot of well-organized data and go to the places where it's more difficult. And so we're building up a shopping list of places where we know there are really quite high temperatures at shallow depths. In some places where there's already existing and often declining infrastructure. So analogous to the sorts of things that Roy was talking about, but in situations where we've really got very high temperatures already providing a nuisance to the petroleum systems and to the gas. So simply saying, okay, let's have a look at some of this stuff and some of your so-called dry wells, which are hot and nasty and too hot for the oil, and just see what we can do with those systems. We know they're permeable. We have a lot of information on the stratigraphy and the structure. So the sorts of things that drive folk mad in onshore geothermal in the traditional plays, where they're almost having to drill blind on the sides of volcanic systems. All of that geological risk goes. So that whole thing that Kirsten's pursuing there, absolutely, we think works in many places, and actually in hotter places around the world also. But then I wear my mad geologist hat and go into these deep waters that Roy is wanting to frighten me away from. The first thing, we've all seen the pictures, these huge ocean spreading centers, the whole, huge belts all the way around the planet. Yeah. They're bigger systems than the so-called ring of fire, and they're continuous systems. And so you've got a huge geographic footprint, a large thermal flux. And I absolutely agree with him, but for completely different reasons. The vents we need to avoid, because the modeling we've done is telling us actually those are the places where we've got the circulation of ocean bottom water going into the crust, actually cooling things down. There's thousands of kilometers of spreading center away from those vents. And I'll come back later in our discussions about, there are plenty of unknowns there, but there's a lot of places where we're interested in the geothermal heat that's not leaking the seabed. So it's the offshore equivalent of the so-called hidden geothermal systems onshore. So we think there's a huge amount of power there. And to give a scale for it, even if we just say, well, today the petroleum companies can drill in 3 kilometers of water. Routinely they drill in 1 kilometer. So we would say, right, okay, one kilometer, look at the parts of the spreading centers that are in relatively benign met ocean conditions, so mostly the tropics, we're talking about sort of 6 terawatts plus of energy sitting in these things. If we use sort of Iceland as a very crude analog for what sort of energy yield may come out per square kilometer in these things. So it's a huge potential prize if we can sort it out. At the same time, we know, there are people exploring for metals on those spreading centers. And so there's the option there of co-production, a theme that both Roy and Kirsten were talking about, co-production of critical elements that could again improve that whole economics. There's the work being done by Carbfix on Iceland, good, injecting into hot basalt is for fixing CO2. So just as Roy was talking about the importance of pulling together a lot of different technologies for economic benefit, we can actually pull together an awful lot of other resource extraction processes and get to some sort of Goldilocks zone where, despite the high cost of drilling in these depths, we can actually get to something that makes economic sense.
Yeah.
And then the bigger picture, we're doing this, we're not using land, we don't need water, we're in places where there's low magnitude existing seismicity. So we're not going to start creating magnitude 7 quakes that are too weak. So there's a whole raft of things that are risks to be sure that we don't have in that offshore setting. Over time, we're going to have a pile of technology from the oil and gas side that is really looking for somewhere else to repurpose itself to. And that if we can get a big global footprint energy system like these spreading centers sorted out and understood, and that's a really meaningful way of moving forward.
I agree, Rob. I'm not the one to be convinced here, but I agree with you. I think this gives purpose, doesn't it? It gives purpose to a lot of technology out there. But there are questions, of course, on cost and what to do with the fact that we are so far offshore. Where do we land, et cetera, et cetera. But I'll come to that. I'll quiz you later on that. First, Danielle, I want to ask you a couple of questions. First of all, it's awesome to have Repsol on board. And you already discussed a little bit for the portfolio you're running, you're screening geothermal opportunities, and offshore, here you are, you're screening for an opportunity offshore. What's your vision? And when we speak about offshore, what does it mean to you, and how would you describe offshore geothermal as the opportunities and the big wins?
Yeah, well, first of all, I would like to say that I mostly agree with everything that has been said up to now. And while the conversation wasn't going out, I was always thinking about the thermal side of it, because we've been doing offshore geothermal for a while already. Whenever you're mixing fluids to enhance, for example, separation efficiency in oil and gas, you're doing offshore geothermal. No? So the thermal component, I would say it's not so crazy to think about, no? But maybe that's a very local solution, that helps you when you have 2 fluids next to each other and you just benefit from it. On the other hand, the electrical side of it, let's say the power, our vision on geothermal has started being related to abandonment costs and how to reduce that, how to give a second life to our assets, how to give a second life to the huge data sets that we have available on the different layers that we may use. Maybe for geothermal, I also wanted to mention that geothermal can be just a building block of something else. If you're going for CO2 storage, you may have the opportunity to power your facilities with geothermal power. No, so geothermal may not be the end user, but an enabler of other technologies that you would like to implement. And for this, I understand that the key factor to make this a success, at least in the early stages, is to do something in an area where you have a lot of infrastructure. No, that's where you can actually find out these, let's say, quick wins that will help you build up later to maybe more frontier areas or more innovative solutions. Because in the end, you do have the technology for drilling, you have the technology for the right completions, you have modular equipment in order to extract heat and transform it into electricity. And many times the problem is, does the business case close? Can I sell that electricity somewhere nearby to somebody? One of the examples that we analyzed, we had a 40-kilometer tieback to the next facility. So the cost of sending that electricity elsewhere didn't really help you with the business case. No? Yeah, one last point I wanted to mention on these building blocks. No, you may have opportunities associated to the quality of the fluids, lithium extraction. There are some companies that are not looking for geothermal, they're looking for lithium, and they are just using geothermal as a side effect, as a co-product, no? That they are benefiting from. So there's a number of things, and just like Roy was saying, I'm very much of a fan of working with a catalog of opportunities, no? And integrating them, or just picking which one of them makes more sense for a particular case. Each case will be a specific analysis, and geothermal is a very relevant building block, and what we're trying to do is keep it in the picture, not keep it in the, okay, we always consider geothermal, maybe you scratch it off at the beginning, but it's part of the equation from the beginning.
And Danielle, I'm sticking with you for a moment because there are also a couple of questions coming from the chat, but also what I wanted to ask you already is about how you screen those options as a viable business case going forward, because cost is of course an element that makes your business case fly or die, basically. So can you comment a little bit on the costing element and hence also the risks involved of producing geothermal fluids offshore?
Several objectives, no? You may have, you have to combine just economics with your net zero emissions objectives, no? So sometimes the most net zero is not the most economic, but in the long term they will, because whenever you're doing these business cases, you have to include also carbon taxes, how much CO2, not only for that particular facility, but maybe at your whole portfolio, that with one, you may be compensating the emissions of others. So tax cuts for CO2 are part of the whole business case. I mentioned lithium. That's another, again, a byproduct that can help you with the business case. So what internally we have a very, I would say, a straightforward tool for screening, early screening of opportunities. But whenever we may get into a more deeper analysis, we're trying to make sure that we're not just looking at how much can I sell the electricity for, but what are the other byproducts? And again, CO2 carbon taxes are also very relevant. No? Let me also say that when we're doing the business case, sometimes we think that the focus is more on the facilities, et cetera, but in the end, the OPEX is also a very, very relevant element, no? Particularly when you're looking at repurposing oil wells, that you look at the integrity, necessity of workovers, maybe you would need organic scaling, you may make you need OPEX for inhibitors. So the economics, or even if you need a pump, because Roy was saying very correctly that you would prefer to have something overpressurized. You don't need a pump to work with it, but many times that's not the situation. So that pump will have your business case maybe if your energy consumption is high. No? So there's a lot of elements, barriers as I mentioned, but also opportunities as byproducts to make the right business case.
Great, and I think final question to you before I move to Roy, because it's an interesting one that popped up in the chat, and that is: are oil and gas entities really taking this seriously? And what's Daniel's view on the coming, let's say, 5 to 10 years on offshore geothermal? And just a few words on your behalf would be great to comment quickly on that question. Danielle?
That I'm on the group of Repsol, no? So we are the one sometimes the bit into this opportunity. So I'm a big fan of geothermal. Internally, the awareness of geothermal is increasing, no? And as I said before, the business is already looking for opportunities. So Repsol is taking this seriously, yes.
Good, excellent. Okay, Roy, I am going to move to you. And we've discussed this as well, I think already a year ago, when we were talking about offshore platforms, abandoned wells, abandoned platforms, decommissioning, opportunities for hydrogen, ammonia, these hydrogen factories in the GOM, etc. I read in the news this morning that the Dutch have funded a green hydrogen producing platform fed through wind energy, so offshore wind to Q13A, which is of course very exciting. But I say to this, Roy, we can also do that via geothermal, can't we? Can we produce hydrogen offshore? What do you think about that?
Can you produce it? Yes. Any place you can make electricity, you can produce hydrogen. If you take advantage of the heat and the pressure, you can increase the efficiency of producing the hydrogen. The issue then becomes, how do you transport the hydrogen? And how do you get it where it needs to be? Because I've heard talk of repurposing the existing gas grid, that is a non-option. That doesn't work. The existing carbon steel pipelines cannot handle transmitting hydrogen. Anything over about 5%, and you're risking catastrophic failure of the pipe. And that's not being dramatic, that's what will happen. And as far as converting it to ammonia to transport, ammonia is a really useful industrial chemical. It's not one that you really want to be trucking around great quantities of all over the place, because it's also a very deadly chemical in its pure form. So it's not one I would recommend as using for hydrogen transport. So the production of the hydrogen, yes, geothermal is great for that. Any of the renewable energy sources are great for creating green hydrogen. The question becomes the distribution. So what we, again, when I get asked about this, I will generally counsel focus on replacing the hydrogen in the refineries. The reason being is because they use a lot of hydrogen, but it's used in the industrial settings currently. Most of that, almost 99% of that, or something like that, 98 point something percent, is either black, gray, or blue hydrogen, depending on what definitions you're using. Blue is the gray hydrogen where they've done the CO2 capture on it as well. But it's not something that you want to be trying to put into transport systems and things like this on a regular basis. There are spot uses of it, I'm sure. But you're going to have to, if you do that, you're going to have to replace the entire gas grid, and that has a huge carbon load. You've got to pull out the ones that are there. You got to put in new ones. You got to build the steel pipe. It's still a steel, but it's a very specific alloy that you can use to transport hydrogen. Or you make them out of composites, but to build them out of composite, then you need more of the petroleum products to make the composite tanks to hold the hydrogen. That, yeah, you kind of get into a circle. So can you produce hydrogen? Great. Yes, you can. That's an easy answer. What you do with that hydrogen and what your target market are needs to be a little more focused, in my opinion, when they talk about the green hydrogen and the hydrogen economy. You lose, if you're producing renewable energy, if you're anywhere near a place you can sell electricity, it is far more energy efficient. The best commercial electrolyzers right now are only about 60% efficient. In other words, you'll lose 40% of electricity energy generation when you convert it to hydrogen. To transport hydrogen, you're going to lose more than you do with gas. You'll lose up to 10%, 10 to 20%, depending on what system you're using to transport it. So that's another loss. And so by the time you get it into whatever you're using to make use of it, you've already lost a whole lot of the renewable energy that you produced. So, but if you send it to the refinery, it's going to get, at least you're replacing the hydrocarbons that would be used to make the petrochemicals that we need anyway. And it's the same thing with ammonia. I mean, ammonia is used a lot as an industrial chemical. There's a reason why they tend to make it in the refinery they're going to use it in, because you don't want to transport it. There are a couple existing places where they transport ammonia, but that's only on a case-by-case basis. It's not something that's commonly done. It's usually produced in the refinery, sent to the other side of the refinery, and used.
Right. Yeah. But that's a very interesting observation that you make, that the production side not a problem, okay, but the distribution side, because a lot of
and storage. That's
yes,
where
exactly.
That's where hydrogen has, and they don't address it because there isn't really an answer.
Right. Okay. Interesting, because I do think that part of the advocacy around green hydrogen is the use of the existing pipeline structure, and hence. Now you're saying, Roy, no, that's not possible. Okay, we'll come back to that.
There's a couple of distributions. At low pressure, you can put it in the steel pipe. So distribution systems, in particular, UK is kind of an outlier because their system was designed on coal gas, which is a syngas, basically, which is hydrogen and carbon monoxide. They can handle higher levels of hydrogen. But if you take it down the road, it's not just the pipe. The valves don't seal hydrogen. It's a small molecule. It tends to leak through things. Your meters don't work. The scenting agents don't work. You can't put the scenting agents they use now are too dense. There are other things you can put in there, but if you put the scenting agent in hydrogen, so you know when you have a leak, then you can't use it in your fuel cell because the fuel cells need really pure hydrogen. So again, there's all these little things that they tend to not mention when they're talking about we're going to go to a hydrogen economy. And there are places where there is no alternative. It's great. But for anything else, if you can use electricity directly, it's always going to be more efficient. It has to be. And that's you don't get around the thermodynamics involved.
Got it.
Yeah, I add a couple of
Sure.
comments.
Sure.
You can transport just a little bit of hydrogen. It's 5–10%.
2 to 5%.
Yeah, not excessively, so not 100% in the current lines. What I've heard, and Repsol is part of a consortium that is helping FMC to develop a concept called deep purple that would use hydrogen as a cushion. No? You would produce electricity with wind in this case. You could use geothermal, of course, no? But later on you may have periods where you don't have demand, but you have the opportunity, but you cannot sell the electricity. So you produce the hydrogen just as a storage and store it for later use. And again, it's not efficient at all in terms of the percent that Roy is mentioning. No? I also highlight this because they're also studying different pipelines, no? Different composite materials that would be more efficient. But again, how developed is that? What's going to be the final cost? I honestly don't know. So I don't know how big that market can be. And for sure, if you can, just like with geothermal, if you can use geothermal for thermal uses, that's the most efficient thing. No? If you have the electricity, why convert it into hydrogen? Because you're going to be losing a lot of the power that you have generated, right? But I do think that it's an area that, again, maybe in 5 years to come, we will have a different opinion because things have developed in the right way, fast way. But right now, hydrogen offshore has a lot of, let's say, challenges, just like offshore geothermal.
Got it. Okay. I want to slightly move away from the hydrogen topic and bring us back to certain specifics. And I do not specifically like the word obstacles, but we see, of course, quite a few obstacles when it is about pursuing the opportunity for offshore geothermal. So, Kirsten, I'm going to move to you, given that, first of all, you have a consortium that has an aim to work in the UK. So you have been reviewing opportunities. And regulation is always both onshore, but also offshore, of course, a very important, let's call it a barrier. So how big of a barrier, Kirsten, is regulation? What are your observations there?
Yeah, thanks, Mark. That's an interesting question and one that we've recently explored for the Net Zero Technology Centre in Aberdeen in collaboration with our partners at Aberdeen University, the law department there. So, and how we went about that was we looked at future offshore geothermal scenarios. What are they? Well, first of all, you've got co-production, then you've got repurposing, and then you've got standalone or greenfield geothermal. Now, bear in mind that here in the UK at the moment, there's no real licensing regime for geothermal as we'd understand an oil and gas license works. So the main focus really is on environmental and around preventing contamination of groundwater. So already offshore is a different fish. But essentially in a co-production scenario, the water is already produced within the remits of the existing license. So there's no big change there. From a regulatory standpoint, we're pretty much good to go. Now, once you move away from co-production, then it's less clear. And that's when it becomes valuable to draw analogies with other regulatory regimes, such as CCUS. And I say that because, well, I'll use the UK case as reference here. The Oil and Gas Authority here in the UK is responsible for licensing oil and gas acreage. And quite recently, they've also been tasked with CCUS. So does it make sense for them also to regulate geothermal? Now, taking that a step further, and I love this bit, is, and what will the energy licenses of the future actually look like? Will it be a requirement to harness the whole energy value of the resource? And by that, I mean wind, tidal, solar, hydrocarbon, mineral extraction. And that's picking up on a common theme that some of my fellow panelists are speaking about, that idea of integrating the energy resources. But going back to regulators, well, they only get involved if there's a business case and projects that need regulation, chicken and egg situation. That space is starting to get interesting, but the industry needs to be interested in offshore geothermal for the regulators to be interested. And that brings me back to a point that I made earlier, that demonstration and representation are crucial in this space. So in summary, going back to your initial question, is it a barrier? No, not necessarily. It will be sorted out when there's a business need, but we should start involving the stakeholders now to ensure that we have a fit for purpose regulatory framework, that geothermal gets space in that framework. And I wouldn't underestimate the time and effort that will probably require.
Yeah, I think that's it. That's spot on. I think time and effort in order to get geothermal mapped into regulatory space has already been proven very difficult onshore. Let's not underestimate the time it will probably take to map that into the offshore space. I with you. Thank you very much for that answer, Kirsten. I am going to move to Rob. Because you gave quite a broad encompassing vision for offshore geothermal, and I think there are two parts of the question I want to ask you. One is, and someone picked up on it in the chat as well, you know, are people out there, in your opinion, are people out there really looking for, let's say, fit for purpose opportunities, i.e. drilling wells, completely new wells, exploration and producing of new energy assets specifically for geothermal, and not, let's say, quite of the few topics that have been discussed today is looking at already existing oil and gas assets. So Rob, that is one thing I wanted to ask you. Part of the question is on that, other part is on partnerships. What kind of partnerships do we need if we want to grow the vision and hence also some activities around offshore geothermal?
Okay. The key to the question about how seriously are people looking at these things still comes down to, can you make a business case for it? And what we're seeing is this thinking about cascading resources in different geographies makes a big difference just in gross terms and gets people thinking about the business case, even in relation to spreading centers in different situations. Trying to do economics on it is a real challenge, because in the space of 12 months, and Roy will have a real map of this, the way in which prices are changing for different types of, for instance, hydrolysis, converting hydrogen to ammonia, companies thinking about converting shipping engines to ammonia. So suddenly you start thinking, maybe an offshore development, and we just basically, they become ammonia refueling stations for the global shipping fleets. These things become really quite big picture things which have a cost, but also have a huge value. It's a sort of, you know, Mark Carney's story of, you know, don't just look at things in cost terms, and have a think about value and whether basically the world wants to pay for that in order to get green energy moving much quickly around the planet. So the answer, I mean, the hard answer is no, until we can make that direct case. Part of that is the economic story, which is shifting under our feet, but always in the right direction. We're seeing the running costs of deep water development coming down and down and down in the oil and gas side, such that it's actually cheaper than some of the running costs of quite a lot of fields onshore. So you think, okay, with all these different technologies, the trends are all moving the right way for us. So somebody has to juggle that magic crystal ball from that point of view. But the potential, I mean, as you can see, if we're even half right, I mean, it's a huge, huge resource and it's scalable. Technically, it's doable now with the technologies we've got. So it could make a massive difference to pulling down CO2 in the atmosphere. But if we're going to do it, then the sort of things that Kirsten was flagging up about the regulatory side of it, that's one millstone immediately, each time sort of domain to it. So the things I'd put on my sort of partnership list, I wouldn't start with the geology. I'd actually start with this legislative side. I don't care whether we call it the chicken or the egg, but the UN, you know, has a remit to look after and development of the resources for all the international waters. by no means all of the spreading center resources into water, but quite a lot of it is. They already have legislation to do with mining. Could they not be encouraged to start developing a sort of template for hydrothermal offshore, geothermal offshore, that could save all the individual countries who in their own national waters need to develop these things? Have something which becomes legislation in place, which helps anybody with international waters to get moving on this, pick up all the lessons from the sort of things that Kirsten was talking about, and not have every single country reinventing this wheel in a different shape. And then people like the oil and gas industry would go, okay, there's actually something here where we understand the legislation. Now we can sort out looking at the actual costs.
Yeah.
Legislation, who knows what the target is?
Yeah.
So I'd say a partnership between the International Seabed Authority that administers the UNCLOS legislation, and the countries and the companies, oil and geothermal. That should be something we try and encourage to get started. Even if in the end, the whole thing turns out to be completely bonkers. The potential of this is actually really very, very large. And to discover in 5 to 10 years, it really is very, very large. And then we've got another 10 years of trying to get the legislation sorted. I think it makes sense to get that part of it, the legislation going now, in parallel with the other things that we have to do, which is filling in our ignorance on the geology of the spreading center systems. So the partnerships of the national research centers who've been doing work on these spreading centers, many times saying, hey, there's a lot of energy here, but they're still tiny pinpricks compared with what we know about the millions of wells that have literally been drilled in oil and gas exploration. The wells that have been drilled close to the ridge crests, very, very few. For good reasons, nobody wants a geothermal system, without having a proper oil and gas company control system on it. So get all those groups and push forward again with a new energy on scientific research. Both to identify the places that we want to avoid for exploitation. There must be other vents that we don't know about yet. And all that information will help us in thinking of particularly permeability and flow rates and temperatures in the other parts of the ocean systems where the stuff isn't breaking to surface. And then the last one, of course, is, and I don't think this is urgent because the technology is changing so fast, but getting the drilling companies, the logging companies, just what Roy is doing, pulling together the surface facility group so we can understand the direction of travel. That can then also give us a basis for prioritizing where in this huge geography of the planet with spreading centers underlying it, where might be sensible places.
One thing I want to make clear just real quick, Merritt, is that when I talked about the vents, and Rob was correct, the vent systems are localized, and the spreading is everywhere the plates are moving, there's a spreading event, and they don't all have vents. And so he's absolutely correct. Now, as he also says, it's in international waters, and Rob, you probably read this more recently than I have, the law of the sea, which is what you're talking about there.
Yeah.
Does it still have, though, the technology transfer requirements, which it used to have, which if you wanted to do anything, your stuff basically had to become public domain.
So and there's certain things there which I think are good practice that we should be adopting in offshore geothermal. So the environmental impact statements would still become public domain and would involve independent environmental researchers.
I'm talking about the development technology. That's what you used to have to transfer.
Yeah, that I'm not so clear on.
Oh.
And if that becomes a case, I mean, certainly there's transfer of acreage, in that mining legislation. I mean, the transfer of technology I don't know, Roy. Yeah.
It used to, I went back in the 80s. There's a lot, I mean, I haven't read that since probably 1990. And back, there's a section in there where if you develop a technology for doing anything to exploit the international waters, there was a UN body that has never been used that was meant to then take whatever technology you developed and disseminate it to the nations that didn't have the wherewithal to do so.
Oh, okay. I'm going to stop this discussion a little bit because it's very interesting. And I would say let's all go to COP26 in Glasgow and vote with the UN for setting up an offshore geothermal research group. I'm in. Kirsten, this is a question for you, and I'm sure you can handle a very detailed technical question here on specifically power systems. And given that you have, let's say, some experience in the UK offshore, what power systems are you considering? What power systems are you looking at? And are they on platforms or are they on the sea floor?
Yeah, another great question. Everything starts with the resource. So really, it's dependent on the temperature of that resource, what power system you would tag on to the top of that. Now, a lot of we have HPHT assets in the UK, of course, but we also have a lot of lower enthalpy geothermal. Now, in the first instance, that is turning lower enthalpy geothermal to power is perhaps not so commonly done. But then if you look at the business case in certain fields, especially if they're important fuel gas, then you start to see how there is actually merit in looking at how we can turn lower enthalpy geothermal resources into power. So that's, and if you're doing that, you're talking about binary, so you're talking about organic Rankine type systems. This is when the production model potentially starts to diverge a bit. If you're then looking at closed loop systems, you're looking at speciality fluids, you then start to see how co-production then perhaps starts to go into repurposing. And those are the different models that I was speaking about when in the previous part. So I think also that in our experience, this space is ripe for innovation. And we've seen the low enthalpy heat to power space, that's moving really rapidly, and that's very interesting. If you can start to open up cascader systems, if you can start to open up that window in which you can generate geothermal power, then it becomes a very viable option to some of the clients that we have on our books. In terms of looking to the future, TEGs, love it. And I think it's really valuable. I think there was a session yesterday when they were kind of picking that to pieces in a technology sense. But we are certainly looking at co-production as one specific scenario. And we are definitely looking at what models, how do models need to change when we're moving into that repurposing space? And again, going back to the points that all the panelists have made, looking at interrogating the data that we already have, finding projects and demonstration sites is so super valuable. And we have those opportunities offshore under the right circumstances.
Nice, love it. Thank you, Kirsten.
Yeah. I just wanted to emphasize the fact that from the view of power systems to produce the electricity, the overseas, you have very modular solutions. So sometimes these questions that come up, oh, I don't have space in the platform. You're looking at things that are quite small that may have an opportunity to be installed there that may give you 300 kilowatts, maybe not 2 megawatts, but in the order of the hundreds of kilowatts you can get there. And yeah, that's what I wanted to say.
Well, and Danielle, this is maybe a nice question for you as well that came out of the chat, and that is when you're screening those opportunities, you're also looking at your own platform, so to speak. So the existing platforms that Repsol and maybe in joint ventures that you're having. So how long can these platforms remain operational? Can that be several decades? And even someone says, or maybe even a century, as in 100 years. To what lifetime are you modeling your opportunities?
Interesting point. Let's see. Normally, they are designed for 20, 30 years, but you can get extensions on that based on analysis done particularly. And I know Roy is smiling because he's been working one of them that just got commissioned in Repsol. So yeah, that particular platform got an extension for several years. I don't remember right now how many.
10-year extension on its 25-year design life, but I've worked on platforms that are 50 years old.
Yeah,
as long as they're maintained, they don't go away. But a lot of times they're allowed to run down because they're getting near the end of the reservoir.
So you can work on that on a specific basis and see if your platform would stand for 10, 15, 20 years more after you have decided to do this transition.
So I guess, I mean, part of that implicit assumption then in such a question is that if we're able to have an offshore platform already, you know, well maintained, obviously for 50 years, you could probably drive at a very low cost of energy, of electricity, if you manage to get your production of your fluids into shape. So would this be extremely helpful for producing absolutely cheap electricity offshore?
And in fact, that's something that right now we're looking at old wells, all installations that did not think about geothermal at all. But what if from now on we start looking at the full life cycle of saying, look, at some point this is going to be watered out. Can I still use this well to produce electricity and have a holistic view from the beginning on the potential of thermal component of oil extraction?
I think that is very interesting in general. And I think it is also a very nice link to another question that popped up. And that is, are the pressures that we encounter offshore, so in our resources, reservoirs offshore, is that particularly helpful for geothermal production? And Danielle, sticking with you, maybe you answer first. And Roy, given that you have some experience there, maybe it's good if you could tap into that.
Go ahead, Daniel.
And if the reservoir is over pressurized, that's going to be helpful, but that may not be the case, that you need artificial lift and extra power and a pump to bring the fluids to the surface. So it's really dependent. I don't think you can generalize on pressure. No? If it's there,
that would be my answer as well. It depends. There are cases where the overpressure is sufficient that it gets rid of that parasitic load of having to pump any fluids to the surface. There are places where the temperature and the reservoir characteristics, and the platform he's speaking of is like that, where you'll have to put energy in to get the fluid out, but because it also has a very low pressure, it's easy to inject into. So to get that closed loop going is easier than if you have a high pressure system. So I won't say it's a wash, but there's ways to skin the cat, but you have to look at each one individually, and you have to look at same with the platforms. You're asking about the platforms. In the Gulf of Mexico, when I started at Excipio 5 years ago, there were 3,500 platforms. They're down to 1,700 because they're ripping them out pretty good pace, of which at least half of them had to go. I mean, they were well past their expire date. But if you build a platform and maintain it, I've had this conversation with the regulatory folks here, any installation, any offshore installation, you're still going to design it for 25 or at most 50, but usually 25 years, just because it becomes too onerous to build after that. But if you maintain it, in theory, there is no end date. So there would need to be a maintenance and inspection requirements that would be different than they are with oil and gas, maybe to a higher level. But you'll in theory, the lease doesn't expire. You've got not just 20 years of reservoir, you've got an infinite, in theory, reservoir. Doesn't run out.
And one more point, because the question was if it makes a difference offshore. I would say offshore, and paraphrasing Lev Ring from Sage Geosystems, he said, and I agree, that the difference is the flow rates. Normally the wells generate much more flow rates. And the fact that you have an environment that is cold, that could, part of the facilities, would be much easier to do because you have a very good cooling system for the end of the process. Not so much pressure because that's very case dependent.
Okay, very good. Kirsten, I have one specific question for you, and that is, you mentioned the Aquarius Consortium in the UK offshore space. Could you briefly describe the goal of that consortium, working with your partners in the consortium?
Okay, yeah, so our partners in that consortium are DCX, based at London and Dublin, and Ross Offshore, who are a Danish-based company. They have a lot of expertise in drilling geothermal wells. So the idea behind that consortium is, I mean, we all have an oil and gas background, right? And I've spent the last 7-8 years working in geothermal, but I'm a wells, I have my history is in well construction. So the focus there was really to try and bring almost an oil and gas mindset to looking at the reserve, categorizing the reserve, and then looking at what we can do with that reserve in and around the assets that you know our client base is in. Because what we find is that a lot of it's mindset, right? And a lot of it is interrogating data with a different set of glasses, really. And that's something that we have experience with, not necessarily the oil and gas operators, although they, you know, technically they have the skills. The mindset is somewhat different. So that's what we bring to that space. And then also looking at, so we look after the top side stuff, DCX look after subsurface stuff, and Ross look after the well stuff. And that integrated approach is really attractive to oil and gas operators. Typically they're organized like matrix organizations. It's quite difficult for them to organize themselves perhaps differently. So that is something which is certainly seems to work well. And I think the beauty of having that collaboration is that we each have a different focus on, you know, where our kind of passion lies, and we're looking to bring different technology options into the heat to power space. And I know that our other partners are looking to innovate in the spaces that they're in as well. So that really works quite well.
Excellent. Thank you. I have one more question and then I have to go already into the final remarks stage. As I said to my panel beforehand, time flies. Final question, Roy. I think this is a perfect one for you to take, because there were a couple of questions around how to choose the best platform, basically, or how to choose your best asset, your candidate for bringing, for instance, electricity onshore when it comes down to geothermal offshore. What's your observation there, Roy?
In terms of a best platform, that doesn't have an answer. There's none of the platforms by themselves have an advantage over the others. With regards to bringing power to shore, the advice I give there is you sometimes want to think outside the box. For example, you can't repurpose the pipelines for carrying hydrogen, I mentioned, but you can repurpose them to carry water. So if instead of transmitting electricity, you pump the water, you can actually capture that energy onshore by the turbine and also put it into pump storage if you want to store it. So repurposing the pipelines for that kind of energy transmission, your actual energy losses are considerably less than if you do it with by doing it by hydrogen. And you can even couple that in places where they have water shortages like California. You can couple that with desalination and you solve two problems at once. So this is where I say you have to, it's not so much of thinking outside the box, it's don't even consider the box. Again, I've been asked by this question an awful lot. So what I tell people, tell the oil companies to do, take the problem you have, go to some college students that don't have any idea how you do things now, and tell them, this is the problem, how would you solve it? And I guarantee you'll get better answers back than if you just go to the industry and ask them how they do it, because you get back the answer that they're already doing, not the best way to do it.
Fantastic. On that note, I am going to say my final remarks, and that is thanking my 4 panelists for today. Offshore geothermal has a long way to go, I know, but I think the opportunities are there and the obstacles we will overcome. I am convinced of that. So I'm going to ask each panelist to briefly close out with your final remarks and your final take-home message, and a big thank you again on my behalf. Danielle, I'm going to start with you, asking for your final key message.
I have to start by putting again the disclaimer. Oil and gas industry takes this very seriously. We really see the opportunity in the geothermal. Maybe offshore has more challenges than opportunities for the time being. I'm sure there are quick wins that we can profit and prove the world, just like Rob was saying, we need allies. We may have quick wins to prove the world that this is feasible, and based on that, build on and bring it to scale. No? I really think that assets are our best way to find those quick wins rather than trying to do the blind approach at the beginning, but for sure this can grow later on. So we will continue working on these kind of opportunities, onshore, offshore, elsewhere with geothermal.
Super. Thanks, Daniel, and great having you. Rob, over to you for your final remarks.
Hey, so you've seen we've got still a massive amount of geologic uncertainty in what could be a potentially huge energy resource in the deep water areas of a scale that really could make a really big difference globally. So time is short. So I just say, let's get on and check it out. If it turns out to be actually even quarter as good as I hope it will be, then it's something that really in 20 years time, people will be going, yeah, it's obvious really. Want to do it. Yeah.
Great. Thank you, Rob, and also for your time being here today. Excellent. Roy, over to you for your final remarks.
Just that I see the geothermal as an important part of offshore renewable energy, but it all needs to be thought of as a system and how you develop it up. And I honestly think that the offshore has far more potential than onshore. Onshore, where you've got the wind farms and the solar and even the geothermal, you have to develop them individually, one at a time. It's very hard to link any of the synergies together. They take up land, they take up water. There's all kinds of things that are an issue that you don't have offshore. And you could create enough energy offshore distributed around the world that you don't need to do any of the stuff onshore. And the environmental impacts would actually be positive in the places where, if you've got these industrial complexes, for want of a better way to put it, offshore, they become havens for marine life. They don't interfere with marine life at all. I've heard questions about people concerned about whales getting entangled in the moorings. These are not fishing things. So offshore, I see that as the future far more than onshore.
Thank you, Roy, and fantastic to have had you today in the panel. Kirsten, last but not least, your final remarks.
Final remarks. Well, I would say that, of course, there are challenges and risks specific to an offshore context. But what you could argue is that decades of successful offshore exploration and development should actually give us the confidence to mitigate that risk and overcome those challenges. And if we're serious about geothermal everywhere and at scale, then that means focused and aggressive research, development, commercialization. We need to be trying lots of different things on different levels, and that's as relevant offshore as it is onshore. There are many parts to this to piece together, and don't underestimate the effort in bringing the right people to the table, a stakeholder alignment. Finding the geothermal value in existing well stock is a fabulous low risk starting point to leverage the geothermal industry forward. And this is an opportunity to be excited about.
Excellent. I say thank you all to that, and fantastic to have had you. I'm closing now offshore geothermal, but this is not the last time we will be speaking about this, I'm sure. Thank you all for watching us.
Thank
Goodbye.
you, Merritt. Excellent job.
Thank you.
Thank you all.